Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel Karna Maths Academy. Today in this video, we are going to solve one of the most important questions, which is from trigonometry, from the chapter of trigonometric ratios of multiples and submultiple angles. Here we go. Dear student, the question is prove that sin 2a minus sin a divided by 1 minus cos a plus cos 2a is equal to tan a. So let's take LHS at first. So dear student, in this problem we have to use the formula of sin 2a and cos 2a. So let's recall once the formula of sin 2a and cos 2a. Dear student, the formula of sin 2a, which is the trigonometric ratios of multiple angles, 2a is called the multiple angle of a. We know that the trigonometric ratios of sin 2a is equal to 2 sin a into cos a. And another formula, we have to use the formula of cos 2a. The formula of cos 2a is 2 cos square a minus 1 and in terms of sin a, the formula of cos 2a is 1 minus 2 sin square a. So dear student, in order to prove sin 2a minus sin a divided by 1 minus cos a plus cos 2a is equal to tan a, at first we have to know the formula of sin 2a and the formula of cos 2a. Dear student, in RHS we need the formula. In RHS we need the trigonometric ratio tan a. So tan a means we know sin a divided by cos a. That means the formula of cos 2a we have to use in terms of cos a, because we need tan a. Tan means sin a divided by cos a. The formula of cos 2a in terms of cos a is 2 cos square a minus 1. So dear student, let's take LHS. So the LHS is sin 2a minus sin a divided by 1 minus cos a plus cos 2a. So dear student, let us use the formula of sin 2a. Sin 2a means 2 sin a into cos a minus sin a keeping as it is one minus cos a also keeping as it is. Now we are going to use the formula of cos 2a in terms of cos, because tan a means sin a divided by cos a. In denominator we need cos a. So we have to use the formula of cos 2a in terms of cos a, which is 2 cos square a minus 1. Now let's do calculation. Let's do simplification. Sin a and sin a. From the first term and the second term, we can take sin a common. So let's take sin a common. Then the remaining terms will be 2 cos a minus, after taking sin a common, there will be 1. Remaining term will be 1 divided by, now plus 1 and minus 1, they are equal but opposite in sign, so we can cancel because 1 minus 1 is equal to 0. Now from 2 cos square a and cos a, let us take cos a common. So dear student, if we take cos a common, then remaining term will be 2 cos a. And after taking cos a common, the remaining term will be minus 1, because cos a already we have taken common. Now 2 cos a minus 1 in the numerator and 2 cos a minus 1 in the denominator, both we have got same. That means we can cancel So we can cancel 2 cos A minus 1 from numerator and denominator because both are equal. Now sin A divided by cos A. The remaining term is sin A divided by cos A. We know sin A divided by cos A is equal to tan A, which is the RHS of our given problem. So dear student, let's review once the solution of question number 15. Prove that, which is from trigonometry, from the multiple angles of trigonometric ratios. So dear student, in LHS we have sin 2a minus sin a divided by 1 minus cos a plus cos 2a, which we need to prove that it is equal to tan a. So let's first we have used the formula of sin 2a. Sin 2a means 2 sin a cos a, and keeping other terms as it is, and the formula of cos 2a is 2 cos square a minus 1. We have to use the formula of cos 2 in terms of cos because we need tan a. Tan a means sin a divided by cos a. Then we have taken sin a common. Remaining terms are 2 cos a minus 1. Plus 1 and minus 1 we have cancelled. From 2 cos a square and cos a, we have taken cos a common. So remaining terms are 2 cos a minus 1. Now again 2 cos a minus 1, in numerator and denominator both are same. So we can cancel. Then sin a divided by cos a, we get tan a, which is equal to RHS. So dear student, I hope that you have understood how to prove the problem related to the trigonometric ratios of multiple angles. So thank you. Thanks for watching this video. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.